All right, so in this video, we're going to look at indexing NumPy arrays, and we'll look at both single-dimensional and two-dimensional cases. So I'm just going to make sure that I have got the kernel restart, and we will go ahead and import NumPy as MP. All right, and we are going to define, in this case, we will start off with a single-dimensional example. So I'm going to define my array, and then for now, let's just make that an mp.array, and let's just do simple numbers here. All right, and I am going to maybe eventually compare this to a list, so I am going to make my list, and I'm going to show you that you can take a NumPy array, and NumPy arrays will have a toList method. So we can make a list from our NumPy array. All right, so right now in memory we have a NumPy array. If we just do a real quick check, so it's a single dimensional NumPy array that has 5 elements, and then we have a 5-dimensional or a list with 5 elements as well. All right, so the reason I wanted to kind of get a list and a NumPy array defined is just to show you that a lot of the operations for indexing, especially or a single dimensional NumPy array is going to be very much equivalent to a list. So if I want to grab the first element, right, I can do that in my list by just accessing index position 0. And the same thing if I wanted to grab the first element of my NumPy array. All right, if we wanted to grab that 3, right, we could change that to be index position 2, so that third element, and we could do the same thing with our array object. All right, and then we can also, if you recall when we had list, right, we could index them with kind of this notation. So if we wanted to grab this 2, 3, and 4 in our list, I could say, well, I want to start at index position 1, and I want to go all the way through. So this would be index position 1, 2, 3, but we've got to go all the way to index position 4 because our slicing notation for a list does not include that last index position. So I could say, well, give me 1 through 4 back, and that's going to give me my 2, 3, and 4. And I can do exactly the same thing with a NumPy array. So I could say, okay, 1 through 4. So these are going to look very, very similar, right? So this is giving me back an array, whereas that gave me a list. And you can also do that step notation, right? So if you remember when we were going for a list, I could say, well, maybe I want to go from the starting, start at the beginning of the array, go all the way through the end of the array, and then step through it in increments of 2. Right, so we'll get the 1, 3, and 5 out of that list. And again, we can do the same thing with our array. All right, so up to this point, everything looks the same. Let's just check reversing. So with a list, we can do that same, give me any starting index, any ending index, and let's step through in increments of -1. That reverses a list, and it does exactly the same thing for a NumPy array. All right, so up to this point, what we've seen is, indexing, especially with a single dimensional case, looks pretty much equivalent to a list. There are going to be some differences though. And this again, a lot of the things that I'm kind of showing you throughout this NumPy or the series of videos on NumPy is to kind of prepare for things that you will see later on in a playlist on pandas, if you choose to watch that. So one thing that would be, interesting, let's say that we've got a list, and we've kind of seen this if we were, trying to do operations. So in a previous video, I was looking at doing scalar, trying to modify elements of a list in an array based on a scalar. And we saw that, well, if I try to do my list, +2, that's going to give me an error because that's not defined for a list. All right, but if we did that for an array, right, so here's my array, and if I do, sorry for scrolling, if I do a +2, we can add elements to each one of those. Another thing that we can do with arrays, and this turns out to be really, really helpful, is we can use them to filter. So watch what happens if I put in kind of a conditional expression. So right now my array is 1, 2, 3, 4, 5. What if I wanted to figure out, which index positions are greater than or equal to 3? right? So which index positions contain values that are greater than or equal to 3? So right now we can see, we've got, 3, 4, and 5 are in index positions 2, 3, and 4. And we can actually do expressions like this. All right, and this is actually returning to me. So if we check the types, right, so we're still dealing with NumPy array. So this is going to be a NumPy ND array. All right, so it's going to return, but the type of each one of those elements, let me just grab one of those. So notice this is returning an array. If I put in parentheses, it's still returning an array. So now I can grab elements. So if I want to grab the 0th element, right, that's it. And we can look and check the type of that. And it's returning a NumPy Boolean, right? So it's returning a special bool that is defined with NumPy. And that's one thing to kind of be mindful of because that can kind of come back to bite you in certain cases. Is that NumPy, a lot of times the types that it stores in the array they might look like integers or floats that you're normal, that you're used to in Python, but they might be a NumPy variant of that. So, just be mindful of that. But in this case, it's returning to me some type of a Boolean object, right? So if I were to grab, the last index, right? So it's returning a true. All right, but we can do these Boolean type of indexing, right? Which is really kind of nice, right? So if we wanted to do something equivalent, with a Python list, we would have to write some type of a for loop type of structure to do that. All right, but what we can actually do with this NumPy Boolean indexing, we can oftentimes save this as something like a filter. So I'm going to say my filter. All right, so if there's some condition that I want to check for, is it greater than or equal to 3? So we've seen that my filter comes back as an array of trues and falses. And now what I can actually do is I can provide that filter as our arguments for slicing our array. So notice right here, I'm creating an object called myFilter, which is basically this Boolean array that's created by this conditional on my array. It's getting back trues and falses based on, is the value at that position greater than or equal to 3? And then here, I'm just passing that filter as an argument to essentially that indexing capability on my array, and it's just going to return the positions where that condition is true. Right, so here's our original array, and then after we do our filtering, that Boolean filtering, we can subset that down to only include the values that match our filter. All right, so we could do something similar with a list, right? If we use like a list comprehension, I could say something like val if val, or let's say val for val in my list if val greater than or equal to 3. And in this case, in the list comprehension, I'm putting the comprehension at the end because I'm wanting to filter. But that does achieve a similar goal there. All right. All right, so now let's look at the multi-dimensional case. So what we've seen up to this point is when we're dealing with single dimensions. As far as slicing goes, largely it's going to be the same, syntactically it looks very, very similar to what we've seen with a list. But we also have this capability to do this nice Boolean filtering based on some type of a condition. So we create this Boolean array, and then we can hand that off and use it as a filter to get our NumPy array for just values that match whatever our filtering condition is. All right, so now let's go to a multi-dimensional context. So I'm going to first just define the array. So I'm going to say this is going to be now my array. I'm going to redefine that. And this will be NumPy array. I'm going to build this thing up where it's like a list. All right, so notice I've got my open the array and it's being closed right here. So I just like to split it over multiple lines here so I can very easily see what's going on. And let's make an array. So here's my list, and then that first row, or that first element in that list, I should say. 1, 2, 3, 4. And then let's do 5, 6, 7, 8. And then let's do 9, 10, 11, 12. Close that dude off. All right, so now we should have a NumPy array. that is multidimensional. All right, and I'm just going to go ahead again and make a list of that. So we'll say my list equals my array dot toList. Just again reminding you that if you've got a NumPy array, you can easily make that a Python list as such. Let's just check something on this my list though. So if we go to my list, and then so we can see we got 1, 2, 3 elements in our list, and each one of those elements is a list itself. So if I want to grab that 1, I need to go give me that 0 element. That's going to be a list, and give me index position 0. I just want to check the type real quick. All right, so it does seem that when NumPy is doing that conversion, when you call that toList and it hands you back that object as a list, it's actually converting those types from like a NumPy int to a regular Python int. And just to show you the difference, if I were to go my array, and remember, if I want to do that indexing, in a multi-dimensional way, so let's just look at it as we would have done for a list. All right, we get back a 1, but now if I check the type of this 1, that's a NumPy int. So that's the difference. That's the kind of the thing that I was kind of indicating. And really where I've seen this kind of, be an issue, it's not really an issue. You've just got to remember that you've either got to convert types or maybe do this toList. Is sometimes I'll be working with JSON files, and I'll be running some type of computation, getting back NumPy arrays, and I'll store that in like a dictionary format and try to write that thing out to JSON. Well, you can't write out a NumPy array because first off, that NumPy type is going to be it's not going to be something that can be stored as JSON. It's not defined in the JSON structure, but I might actually get elements out of a NumPy array and try to send those to JSON, and you might get an error because again, these are not a NumPy int64. That's a special type that also is not defined within that JSON schema. All right, so we've got an array at this point. We've got a multi-dimensional array, and as we just saw, if I want to get that 1, well, I can get in the first element in axis 0, and then the first element in axis 1. So we can grab that just like we do a list. All right. We can also, in NumPy, we don't need the 2 separate braces. So I can say, well, get the 0th index in axis 0, and then get the 0th axis or element in axis 1. So we can do this in a single bracket. So we've got 2 axes, axes 0 and 1, and I'm just saying the index position of both. All right. So if I want to grab this 6, right, so remember axis 0 is along essentially in this 2D structure, right? That's essentially going to be along those rows right there, and then the columns. So it's kind of like the innermost is going to be axis 1, so that's our column accessor, and then axis 0 is going to be going down those rows. If I want to grab this 6, I'm going to say my array. All right, so that's essentially the second element along axis 0, so index position 1, and then 1 on the other axis. So that grabs our 6. But we can do this just like this. All right. Now, here's where things get somewhat interesting. All right, let's see if I called a print, if that makes that look a little bit better. All right, so it's still doing it in this nested type of fashion. All right, so if you think about this, this is going to, we could, let's go back to our original definition, right? So this is kind of what, my list can be represented. What if I wanted to get the value 7, 8, 11, and 12, right? We can't really do that with a list, right? So we would have to write some type of a custom looping structure that is, going through and grabbing those particular values. But if you think about it from the standpoint of an array, all right, well, essentially what we'd be doing if we get 7, 8, 11, and 12, we're kind of getting this bottom, right corner, right? And we can actually grab that with slicing as well. All right, so instead of, if we're trying to get this bottom right, 7, 8, 11, and 12, well, we don't want the first element in axis 0. So we can say start at element 1 in axis 0, or index position 1 along that axis. And then we don't want to get index positions 0 or 1 on this on axis 1. So we can say, okay, we'll start at axis position 2. All right, and we can grab out portions of this array kind of using, like slicing within axes, right? So just note that you can kind of use that same slicing, notation that we did for, a single dimension. You can use this for each axis position. All right, so let's just think about this. What if we want to get this column 159 and this column 3711? All right, so again, we want to get 159 and 3711. All right, so basically we're wanting to get all rows, right? So everything across axis position 0 or axis 0, so we can use a colon to indicate everything. And then I can say, well, I only want, get everything, but let's stride across in steps of 2. So start anywhere, end anywhere, stride in steps of 2, and we can grab just those columns. All right, so you have a lot of flexibility in how you can do, accessing certain things with a NumPy array. And again, as we've, kind of already saw in a previous example, right, when we were looking at, that single dimensional array, we could do that Boolean indexing. So now if I've got my array, I want to get back, any value that's greater than or equal to 7, I could do something like this. Now it's returning a two-dimensional Boolean NumPy array, right? And if we wanted to get those values, so let's just say that this was what we call, let's say large values filter. Let's say 7 is our definition of large, right? So now that's actually saving that Boolean filter, and this looks weird. I want to comment here, right? So I'm saying equals. It's like, gosh, what do we do? But remember, the key reason that this works, right, is because when I run my array greater than or equal to 7, what's it returning? It's returning a NumPy array. So this expression is returning a NumPy array, and I'm just assigning it with this equals to the variable large value filter. All right, so that's why that is working. All right, so now I can take my array and do that large value filter, and it's going to return to me just those values. But notice this time it didn't preserve the shape, right? Because when you're doing this multi-dimensional Boolean, you could have some sparsity in there. So it's just going to return to you those values. And this is just going to be a 6-dimensional single, or a 6-element single dimensional vector. All right. Now, again, you could go through and kind of, do something like that with, a list, but let's just kind of look at this from a filtering standpoint. So again, let's just say that we've got, our large values filter is going to be, we're going to say anything that's greater than or equal to 7. What we can actually, if we wanted to make this even more succinct, right, I could just say something like this. I could just do the filter statement right inside the indexing spot. And this is going to be equivalent, right? Because remember, the key thing is this. What is this operation returning? It's returning that Boolean array that's saying, it's true everywhere the value in my array is greater than or equal to 7. So that returns that Boolean NumPy array. So I'm just putting that right inside that indexing, those braces, and then we return that dictionary. Or not the dictionary, that NumPy array. All right, so we time it. Should be pretty quick. It's running many loops, of course. All right, so 1.12 microseconds. Let's see how we would do this with just a regular list. So I'm going to go ahead and put my time it up here. And let's just make a, I don't know, a large values list. All right, and I'll say for row in my list, for val in row, if val greater than or equal to 7, we'll append it to our large values list. All right, and I'm going to run this without the timing first, just to make sure. So we got large values list. It's giving me basically the same result. And again, let me run this one before without timing. All right, so that's giving me that array. And let's save this so that it's clear that the fact that I'm creating an object in this list example is not what's driving up the time. So I'm going to call this my large values array. All right, so I've got two pieces of code. One creates a large values array, and then one creates a large values list. All right, so I'm going to time these two just to see if this method for doing this filtering based on those values in the array is faster. So we'll do a time it here, and then I'm going to do a time it here. All right, so again, we're kind of seeing it, at least for these small types of values, right? Not a whole lot of measurable improvement with NumPy. But then again, as we start getting to more complicated, larger examples, so the real power of NumPy is going to shine once we start getting some of these larger instances. But at this case, when we're dealing with a relatively small array, it looks like the list is pretty efficient. Running it one more time just to make sure. All right, so again, our NumPy array is not doing as well on this filtering as we would see with our list approach. But again, in a later video, we're going to really ratchet this up and kind of see this comparison at large values or for large arrays. And that's where you're going to really see the power of NumPy kind of shine through. All right, so that is going to conclude this video. In a subsequent video, what we're going to do is look at what I think is one of the most powerful features of NumPy, or at least one thing that I use it for quite a lot, and that is generating random numbers.